welcome to Not Just Good, but Great Eats.
Today we will be exploring the fascinating topic of heat, or thermal energy for all you physics folks out there.
We will be investigating the different elements of physics involved when making baked Alaska flambe.
Now, baked Alaska flambe may sound challenging,
but it's really a simple process. You will need some good old-fashioned pound cake, a cup of softened ice cream. Sliced strawberries are optional. 4 large egg whites and 2 tablespoons of sugar to make a meringue. 1/4 of a cup of your favorite strong liquor.
To start out the dish, you will need to take your pound cake, and we just used a small piece, and cut right through the middle of it, just like this, until you have 2 equal halves.
Next, you'll need to take a butter knife and spread the softened ice cream on both sides of the bread and lay berries on 1/2 if you choose.
As you can see, this process is very simple when you use softened ice cream. Spreads just like butter. Ta-da!
Yay.
Use generous helpings because ice cream is good. Now that you have your even layer, you're ready to add strawberries.
Yes.
Then place the top of the cake on top once you are done adding your strawberries to form a sort of sandwich. And cover it with plastic wrap. We're just using nice generic brand. And then it will go in the freezer from anywhere to 2 to 24 hours. So you can add as many berries as you'd like.
There we go.
And make a sandwich.
Make a sandwich. There we go.
Take your plastic wrap that likes to stick together.
Oh yeah.
And just cover it on top so that nothing slides away. And then place this puppy into the freezer.
Now, this brings us to our first segment of physics and food. Let's take a closer look at the processes that will be taking place as well as the materials they will be taking place with.
Speaking of temperatures and materials, milk, the main component in ice cream, is actually quite similar to another material with a boiling point of 100 degrees Celsius. Alcohol? Try again.
Water?
Not just good, but great guess, Maddie! Milk is actually about 87% water and 4% milk fat. Therefore, its boiling and freezing points are very similar to that of water. The difference lies in the solute, which in this case is the milk fat. Just like salt and seawater increases the boiling point, the milk fat in milk increases the boiling point by about 0.2 degrees Celsius, just above water, considering that both of the materials are at the same atmospheric pressure.
Just like the concept of freezing point depression, a solution like that of water and milk fat would have a lower freezing point than that of just water.
You are correct, Maddie. You can even track the energy used during the change in temperature as the ice cream freezes by using the mass of the material multiplied by the specific heat capacity and the temperature change.
Wow, I guess you could almost say that the main ingredient in ice cream is water then, right?
Guess you could now. Because of the magic of Great Eats, we have been able to speed up time to continue on with our baked Alaska flambe experience. Once your ice cream has gone through its phase change, it's ready to be meringuified.
That's right. Now to make our meringue, we will beat the 4 egg whites with our electric mixer and slowly beat them and then add 2 tablespoons of sugar. Now because this process takes a little while, we'll use a pre-prepared meringue to continue on with the process. Simply spread it over the cake until you have a nice even layer, just as Becca is doing.
Next, place the baked Alaska flambe into the preheated oven at 400 degrees for about 2 to 4 minutes, or until the meringue is golden brown.
While the meringue is baking, we will head to our second segment of physics and food to talk about what process is taking place.
The meringue is undergoing a chemical reaction. The temperature is not the only thing that's changing this time. Therefore, it's not just a phase change. We know this because we cannot get back to the meringue that we started with once it has been baked. This lets us know that a reaction has taken place.
Once your meringue has turned golden brown, remove the cake from the oven. Now, this is where the fun part begins.
We have our liquor heating on the stove, but not to the point where it boils away the alcohol. The alcohol is what is needed to flambe our cake.
Now, take the liquor and coat the bottom of the plate that the cake is sitting on and move quickly to a dark environment.
Now, with parental supervision, we will undergo yet another chemical reaction. Take a match or a lighter and with great care set the alcohol on fire. Voila! Baked Alaska flambe! Ooh.
You now have both a scientific, fun, and delicious treat.
We hope you enjoyed making Baked Alaska flambe and learning neat physics with us today.
Come back soon, and remember, it's not just good, but great eats.
It's just meringue. Where is it at? It's buried underneath meringue.
Oh, there's some.
It should be good. It's just cake and ice cream.
Is it good?
Nope.
I'm not gonna eat it.
It's really moist. Not the good moist.
Like the nasty moist.
The nasty moist. Like coated in sopping wet ice cream and alcohol.
Ew.
Nasty moist.